Hello everyone, here is FIXST. I'm Anthony. Nice to meet you here. In the coming class, we will teach you the 13 problems how to fix in iPhone motherboard repair. And when the phone get to our hand, only two status. One is the phone can power on, when the phone is cannot power on. If the phone just some function is cannot work, we can check all the function on the phone and we will know that which function have problem and then we just focus on that problem is okay. And when we get the phone is cannot power on, cannot turn on, we first need to do is let it be on. That we can do the next step for the repair. This is our first class and we will teach you guys the iPhone how it's power on, how it work about his principle. When we repair the iPhone, not turn on, no power on, the first we need to know that is how is the iPhone the startup process. If you know that how it work, how it power on, what is possible, and you will very easy to find out the problem. In our online class, every online class we have 3 steps to teach you guys. One is the principle, and the second is how to measure, how to reply, and the three is some case to sharing to you guys to let you guys improve yourself quickly. Okay, now in this time we first teach you guys how is the iPhone, how is the phone, the startup process. Turn on the phone have a important thing is the phone need to power. If the phone have no power, the phone will not turn on. And the power of the motherboard is sent by the battery. If the battery no power, and the phone also cannot turn on. And after the motherboard, after the phone have the power, and we need to press the start button to take it to power on to work. And the battery sent to the motherboard, the power is about 3.8 voltage. And normally this power, the voltage is a little higher. The phone is working normally, it need to the CPU also need to working normally. Actually, the CPU working normally and the phone can power on. CPU want to work normally, it also need a lot of the power. If the power sent by the battery directly sent to CPU and the CPU cannot use this power. So that the design of the motherboard have a PMU, the mean power IC. The mean power IC is in order to send the low power voltage to the CPU. So when we press the start button to take the phone to power on, the first working IC is the mean power IC, is the PMU, and it will provide 28 low voltage power to supply the whole phone. And then is the number 3. The mean power IC provide the CPU with 15 low voltage power supply and 1 reset signal. And what is the reset signal? We will talking about detail in the coming class. So in this class we just focus on the phone, how it power on and how to repair it. And after the CPU have the power and the signal and the CPU itself no problem and the CPU will start to work. When the CPU start to work, the first thing he need to do is check itself. He check the CPU itself is have problem or not. After that, the CPU will check the other IC and the low components in the motherboard. Because in the motherboard have a lot of components, have IC and resistor and capacitor and others. And those components cannot integrate in the CPU. And when the phone is power on, and the CPU will check the components itself is the component is okay or not. If the CPU check out the component and some IC have problem, it also case a least problem. So when the phone is power on, the CPU need to check the components in the motherboard. And after that, the CPU will verify the logic prompt. And if you have been repaired the iPhone, you will know that near the CPU have a IC, a little IC is the logic prompt. And this logic prompt have a lot of the information. But if you have not repaired the iPhone, maybe you don't know what is the logic prompt. But no problem. In this car, you just need to know that have these things and how it work, and the more detail we will talking about it in the coming class. So in this time we just focus on the phone how it power on, and the CPU is work normally, and the next IC is the NAND. The NAND need to work normally. So in this time, we just focus on the phone, how it power on, and the CPU is work normally, and the next IC is the NAND. The NAND need to work normally. Because after the NAND is working normally, and the CPU can take out the booting data from the NAND and start to power on, start to booting. And as you can see, this next step is the phone, how it power on the process. So, and now you are understand the phone, how it power on the process. But we can use another more easy way to let you know understand it. First, the phone want to power on have one condition, is the power. And where is the power from? Actually, the power is from the battery. And the second is the PMU. The main power IC need to work normally. So second is the main power IC, the PMU working normally. And after he working normally, he can provide the low voltage power to supply the whole motherboard. Have a lot of 9 liters power. And number 3 is the CPU need to working normally. And the number 4 is the NAND need to working normally, because the NAND is working normally so that the CPU can take out the booting data from the NAND and power on. So that and now you will know more easily the phone power on the circuit, just including the battery power circuit, the main power IC circuit, CPU circuit, and the NAND circuit. So in this time, we one step by one step talking about these 4 circuits to let you know how to repair it. First, we will talking about is the battery powered circuit. In this time, you need to focus on the TV. Pay attention on the TV. The left of the TV is the iPhone 6s, the power on motherboard. Because the theory of the iPhone is always same. It's very similar. So in this time, in the first class, we use the iPhone 6s as a sample to talking about the theory and the principle and how to repair it to share to you guys. And if you can understand all of the iPhone 6s, and you will know every model of the iPhone, because they are very similar. In the before, we have been talking about the phone need to power on. The important phrase is the phone need to have the power. And the power is from the battery. And where's the battery connect to the motherboard? The battery is connect to the J2400 connector. The iPhone 6s, the battery connector have 3 groups the pins. And the pin 4 and pin 6 is the negative pin, is connect to the GND, connect to the ground. And the battery, the pin 1 and pin 5 is the positive power. And this power in the schematic, the name is the BATT VCC. And this is the power sent to the motherboard. Actually, for example, in iPhone 6s, the power have 2 level power, 2 kinds of power. And what is that 2 kinds of the power? The first level, the power is sent by the battery. The name is BATT VCC. This is the first level power. But this level, the power cannot directly used by the motherboard, because this level, the power is so not stable. So we need to exchange it to be a more stable. For example, we use a filter to let it be more clean, more stable. It's like that. The water of the river, we want to drink it, we need to let it be more clean. We need to use the filter to clean it and let it be more clean. And in the iPhone, it seems like that. And when the battery connect to the J2400 connector, we will send now this level the power. As you can see in the schematic, the battery, the pin 5 and pin 1, send out the power, the BATT VCC, this level the power is the first sent to where? At first, it will send to the U2300, the charging IC, and the Q2300, the splitter. And after he go through these two IC, he will exchange to a new level, new power. This power named PP-VCC mean, and this level the power is sent to the PMU, the main power IC. What is this means? The PP-VCC MIA is mean that this level the power is more clean, more stable, and this the level the power is exchanged by the battery the power, because the power sent by the battery is cannot directly used by the motherboard, so we need to exchange it to be a more stable power, more clean power to use in the phone. And the PP-VCC MAIN is this level the power is after exchange. This level is the more clean, more stable power. And the PP-VCC MAIN is this level the power is after exchange. This level is the more clean, more stable power. It is used by the U2300 the charging IC. Use the charging IC to exchange it to be a more stable power. And as you can see in the upper of the charging IC have a Q2300 the splitter. This is you can understand it here as a secondary circuit. It normally just used when the phone is charging. You just know this is okay. Because about this QIC, about the Q2300 this IC, we will talking about more detail in the coming class. So you just know that the battery is connected to the J2400 connector, and this connector, the pin 1 and pin 5, is send out power is about 3.8 voltage. Because this power, this level of power is a little higher and the voltage is not stable, so we need to use the U2300 the charging IC to exchange it to be a more stable power. And after the exchange, the power, the more clean power, more stable power, the name is PP-VCC MAIN. And this level and this power and can directly used by the PMU, the main power IC. So that you will know that the battery is connected to the J2400 connector, and this connector, the pin 4 and pin 6 is connected to the GND, and the pin 1 and pin 5 is sending a power is about 3.8 voltage. And after we know that the battery power circuit, we just need to know more about the main power IC circuit. And before we starting the main power IC, the PMU, this circuit, you need to know that this IC, what is his main function. And you can see the motherboard and you will know that where is the PMU, where is his location. And the main function about this PMU is in order to provide 28 lines the low voltage power of the motherboard. We have been talking about in the before, and the power sent by the battery cannot directly used by the motherboard. And now you will know that the battery, the power sending out, and after the charging IC exchange it to be a more stable power, and this level the power used by the PMU, and the PMU exchange it to be a lot of the lines of the power. And the main power IC want to working normally, it also have two conditions. One condition is power, and the second is the signal. And the PMU, the main power IC itself, have no problem, and when he get these two conditions, one is power, the second is the signal, he can work normally. And the power is used by the PP-VCC mid, and this level of power is original is by the battery. After that, we will starting about the signal part. The first signal is more easy. The first signal is the start signal, the in power signal. This start signal is come from the start key, the power on key. And When we press the power on key, the power on button, and the PMU will work and send and provide a lot of the power to the whole motherboard. And he also need the second signal. The second signal is the clock signal. And for example, it's like a timetable. And if we have not this timetable when we're working, we don't know when we need to do which things, when we need to do what things, right? And in China, we will use the Beijing time as a timetable to do things, right? In China we will not use the US time to do things, right? This is the clock signal. And after we can follow this timetable and we can do the thing one step by one step, do it right. And in the motherboard also the same. In the motherboard, he has this clock, have this timetable. He can let the component know that when he need to do which things, when which component need to start to work, is like this. In the motherboard, he has this clock, have this timetable. He can let the component know that when he need to do which things, when which component need to start to work, is like this. And where is this clock signal, where is from? And near the PMU, near the main power IC, have IC is the Y2200, the clock crystal. And what is this, the crystal, the function? We just talking more easily and let you guys understand it's okay. And the clock crystal will shock in 1 second, have a lot of times. And the Y2200, the 3.2.768 K hertz, this is mean that 1K is 1000 hertz, and the 15.2.768 is mean that he will move in this number in 1 second. And the PMU, the main power IC, will calculate it, how many times he have been shocked, and depending on the clock crystal, he will know the 1 second. And it will making a reference clock signal come out as a timetable to let the IC working normally and one step by one step. And now we come back to the class. The main power IC, the PMU, need to work normally. The first, the PMU, this IC itself have no problem. And after that, he need to two working condition. One is power, the second is the signal. And the power is come from the PPVCC min. And the signal, one is the start signal, and the second is the clock signal. And the start signal is, the in power signal is from the power on key, the start key. When we press the start key, the power on key, and this signal will send to the PMU, and we will know now in this time I need to work. And the clock signal is from the Y2200, the clock crystal. And this crystal will move, and the PMU will calculate it, the times he have been moved, and know that when is 1 second. And then as a timetable to let the PMU working normally. And in the before, we have been talking about the PMU, the main function is provide 28 lines the low voltage to the motherboard. And after the PMU, the main power IC working normally, the next is the CPU need to working normally. And it's same, the CPU working normally also have two working condition. One is power, the second is the signal. And this power is from the main power IC, is from the PMU. And the PMU working, it will send 28 the power lines, right? And including 15 lines is sent to the CPU. And now the CPU is integrate a lot of things, and the CPU also control a lot of function, so that the power sent to the CPU is need to very precise. And this 15 power all is sent by the PMU. And After the CPU get the power, he also need the signal, right? And the signal also have two kinds of the signal. One is reset signal, and the second is clock signal. And the clock signal, you understand it because this clock signal is same like that PMU the clock. Because the CPU also need the clock, need a timetable to let himself know that when we do which things, right? Same. And the other is the reset signal. And what is the reset signal? We will teach you normally and detailed. The reset signal is in order to let the CPU become to the initial state. Take an easily example. For example, when we go to the bathroom, right, we have a button, right, and when we press the button, and it will become to the original state, become to very clean, right? It's like this. This button is like a reset signal. After we use the bathroom and we press this button, and the bathroom will come back to the original. This is same to the CPU. Maybe in that time, the CPU, the inside have a lot of circuit in different state, and when he get this reset signal, every circuit in the CPU will become to the instable state, and so that inside the CPU have a lot of the circuit, and he need to become to the original state, and no matter what he doing before. When he get this signal, he become to the original state and keeping standby and let the CPU let him working one step by one step to work. Okay, when the CPU get the power, get the signal, the clock signal, the reset signal, all is okay, and he will start to work. And we have been talking before, when the CPU is starting to working, and then the CPU, the first thing is check CPU itself to check himself itself is okay or not. And after he check CPU itself is all is okay, and he will do the next step. The CPU will check the local circuit through the I2C bus, the I2C line. And what is the I2C bus, I2C lines? We will teach you guys the more detail in the future. And in this time, you just know that the CPU is use the I2C control line to check the locate the components, check it is okay or not. It seems like our here use the lever to control our board. It seems like the CPU use the I2C control line to control the IC, control the circuit. It seems like this I2C line is the lowest in our here. And after he checked the component, locate component through the I2C bus, he also need to revise the logic EEPROM. This logic EEPROM is also important. And every CPU also have a logic EEPROM. The logic EEPROM inside have a lot of the information, and the logic EEPROM and the CPU is inclusion. They are inclusion. If the information in the data inside the logic EEPROM have some problem, it will also not power on. And after that, it will start to the NAND working. Because if the CPU itself no problem, the CPU load circuit no problem, and the CPU logic EEPROM no problem, it will take out the booting data of the NAND and start to power on. So we are going to study the NAND circuit. The NAND circuit is very easy, because the main function of the NAND is just going to keep the data, to storing the data. It will read and write the data, the information. When we want to keep the information, it will write the information to the NAND. And when we want to checking it, it will read it, the information come out, and you can check it. And the NAND, the working condition also have two. One is power, second is the signal. And his power is also from the PMU, from the main power IC, and have 3 nines the power. One line is 3.0 voltage, one is 0.9 voltage, one is the 0.8 voltage, only 3 voltage. And after the NAND have this 3 voltage, this 3 nines power, he can start to work. And he also need two signal. One is the signal is communicate with the CPU because the NAND want to working. He want to keep and write the data, also controlled by the CPU because the CPU will write the data and keep it in the NAND. And when we need to use the information, the data, the CPU will read the information come from the NAND and send it to the RAM, the IM, send it to the RAM, and we can trade. And okay, the NAND, the theory is very easy. Now coming to the class. In the before, we have been talking about the power on the circuit. One is the battery power circuit, one is the CPU circuit, one is the PMU circuit, one is the NAND circuit. And now we will show you the solution. When the phone get the kinds of the power like this, how we do one step by one step to check it and troubleshooting. So in this time, we first talking about the battery power circuit, how to detect and how to repair. So when we get the phone is not turned on, no power on, cannot power on, the first thing we need to do is check the battery voltage. At first, we check the battery is okay or not. It's very easy because when we do the repair, we have the DC power supply, right? So we use the DC power supply, this machine to power supply, give the power to the motherboard to check it, and we can know the battery is good or not. So we are very easy to find out the battery have problem or not. If the battery problem case the phone cannot power on, it's very easy to repair, right? We just need to change the battery is okay. If after rechecking it's not the battery problem case the phone cannot power on, the next step we need to do is to test the PMU. And we need to check the PMU is working normally or not. So we need to check the PP BTTPCC, this power is normally or not, this voltage is normally or not, because the PMU working, the original power is in this. This PP BTTPCC is very easy to check. We just need to use the millimeter to check it, the voltage, whether it have the 3.8 voltage or not. If the PP BTTPCC this line, the voltage is abnormal, not the 3.8 voltage have a big difference, is you need to check the J2400 connector, the battery connector, and the other load components on this power supply line. If the PP BTTPCC this line the power, the voltage is okay, and this line is very normal, but the PPBCC mean is abnormal, which you need to check the U2300 charging IC. And you also need to check other components in this power supply line. Maybe have the small component, they are short case this line, the voltage is abnormal. And this is the battery detect and reply. It is so easy. And we need to do the next is the PMU circuit detect and reply. And the PMU, the main power IC want to working normally, he also need two condition. One is power, second is the signal. The power is from the BP VCC MAIN. We have been talking about how to detect it. And after that, we need to check is the signal. The signal is one is the star signal, another is the clock signal. And the star signal is by the power on key, the start key. And when we press the start key, the power on key, he not turn on. Maybe it's the power on this cable, power on key button cable have problem, right? If the no power on cannot turn on is case by the power on button cable, we just need to change a cable, it's fixed done. If after we change the power on button cable, still not work, it determines that is case by the motherboard problem. And we have been talking before, the power on button cable is connected to the J4700 connector. And in this connector, the pin 4 is the power on signal. This line After we power on it, when the phone is asleep, we can check the 1.8 voltage in this line. So we want to know that the power on key is normally or not. We just need to check this line the voltage. The 1.8 voltage is normally or big difference. If we check this 1.8 voltage is normal, it means that we can do the next step. But we can, when we check it, is a big difference between the 1.8 voltage. It means that the power on button circuit, this circuit have problem. In iPhone repair, use the iPhone 6s as a sample. This power on signal is sent to PMU and the CPU. So when we check this 1.8 voltage is abnormal, the first we need to check if the line is disconnection, or check whether the PMU or CPU is damaged. But according to our repair experience, a lot of this voltage abnormal is caused by the CPU inside the circuit have some problem. And how should we do if we like this is caused by the CPU? In this time, I need to tell you guys, if the CPU is damaged, this IC is broken or crashed, or inside the circuit have some problem, cannot fix, because the CPU cannot change because CPU and at least the IC is in question, cannot change it, only change it. So in this case, we can follow the 1.8 voltage from other place to make a jumper to follow this voltage to this place. After that, after we make a jumper from other place to give 1.8 voltage to this place, this line, and this line is will working normally. But actually, like this case, is the power on key, this line the voltage have some problem. It's difficult to repair because we have been talking before. Normally, a lot of the case is caused by the CPU inside the circuit have some problem. There are some place, some circuit is burned in the CPU, inside the CPU. And if the burn the place inside the CPU, the circuit, just a little place, we can try to follow the 1.8 voltage to this line to let it try to working normally. But if the burn the place, burn the circuit is a lot, it's so big place, it's hard to help it, it's hard to save it. And if this voltage is normally, we need to do the next step. I need to check the clock crystal, the signal is normally or not. We have been talking before. This clock signal is so important because the PMU need to work normally. He also have the signal condition, right? And if this clock signal is abnormal, the PMU will not working normally. And how should we check it and detect if this signal is normally or not? The most right is we use the oscilloscope to check it. If you have a oscilloscope to test it, to detect it, is so easy. Because this clock crystal will send the 52.768 kHz this signal to the PMU. So we can test this signal. We should know that is okay or not. If the oscilloscope to test it have the 52.768 kHz, it means that this signal is normal. It has a little difference, a big difference, it means that this signal have problem. And if this clock crystal have problem, we just need to change a new one, it's okay. If this signal is normally, and after that we need to test the next step. We need to check the reference circuit component is normally or not. In this line have two resistor, the low resistor in this line. And if this resistor have some problem, he will not send out the information. He will also have the problem. So when we repair the PMU circuit, how to detect? Just 3 parts need to check it. First, to check if the power on key, this circuit is have problem or not. The second is to test the clock crystal to check it is normally or not. The number 3 is the reference circuit to check if this circuit the component is normally or not. And after that, if these 2 circuits is also no problem, we need to detect the CPU circuit. And in the before, we have talking about the CPU need to work normally. One condition is power. The second condition is signal. Where is power from? The power is from the PMU. And the PMU have been sent 15 lines of the power to the CPU. And if this 15 the power is no problem, and he also the signal condition also enough, so we need to detect the signal. And after that, we need to detect the signal. The signal is have two kinds of signal. One is the reset signal, and the reset signal the voltage is about 1.8 voltage, and this voltage is sent by the PMU, and we can test this voltage is normally or not. If we detect this 1.8 voltage is normally, it's okay. If the voltage is abnormal, have big difference, we have to detect the CPU and the PMU. This one of these two things must have problem. And according to our prior experience, we have made a lot if this reset signal is voltage is abnormal is caused by the CPU inside circuit have problem. Most of the case is water damage. Normally is caused by the water damage, and when we detect the 1.8 voltage about this reset signal, this reset signal have not, it's abnormal. I suggest you don't need to repair it, because a lot of case when we remove the CPU, it will be normally. So it means that the CPU inside the circuit have some problem, case this problem. And the number three, we need to detect the clock signal. The clock signal is same like the PMU clock signal, just their hertz is different. And PMU the clock signal is 13 to 768 k hertz, but the CPU he used is 24 amp hertz. Working principle is similar. How should we detect this clock signal? We also can use the oscilloscope to test it. If the oscilloscope show this signal is normally, the number is normally, it means that this signal is no problem. So when we detect it, this signal, the clock signal is okay. If the big difference have not this signal, it means that this signal is sending have problem. After that, we need to check whether the 1.8 voltage of the I2C circuit is normally or not. And we have been talking in the before. If the CPU, he need to detect the low circuit about the CPU. If this low circuit have problem, he will not power on, cannot power on. How to detect this I2C signal is normally or not? As a sample, CPU standing 4 grooves the I2C lines to control the low circuit. And because we know that the voltage of the I2C line is 1.8 voltage, we can detect the voltage of the I2C lines. When we detect the I2C lines have not this 1.8 voltage, it means that this line have some problem. And when we detect the I2C line, the voltage is abnormal. It means that the problem is in this line. We don't need to test another place. We just focus on this line. In this line, which component, which IC have some problem case, this voltage have some abnormal. And how to say, we will talking about more detail in the coming class. And after that, he need to check whether the logic EEPROM has some problem or not. The CPU how to control the logic EEPROM. He also use the I2C lines, because the logic EEPROM is a big difference, because the logic EEPROM is a glass very small IC, and if he have some problem, will case also cannot power, because the logic EEPROM have a lot of the encryption data inside it, and this logic EEPROM is encryption with the CPU. These two things is encryption. Normally we cannot only change the logic EEPROM, because after you change the logic EEPROM, the user data will lost, and you need to remember rumors. If the logic EEPROM have some problem, we need to change the logic EEPROM. After we change the logic EEPROM, the phone also cannot power on, because we also need to flash the phone, because when we flash the phone, the iTunes will rewrite the encryption data inside to the new logic prompt, and then he can power on. If you have not flashed it, you have just change it, not flash the phone will always restart again and again. And we not suggest you change it because the user data inside it. If you change the logic prompt, the user data will lost. But this because this is gas IC, if he has some problem, we only change it and we need to flash. If not flash, the phone will restart again. After that, we will show you the from detect circuit. You can check it in the PPT in the PowerPoint. You can see the data normally. Because the CPU inside the CPU, different place control different function, different lines. And as you can see in the PowerPoint in the PPT, you will see that the PMU send the 1.8 and 1.1 voltage. He will through a lot of the visitor and other components to send to the CPU. And this is the CPU framework detect circuit. And because as a simple, the iPhone 6s and the iPhone 6s Plus, their CPU and other is very similar, but their framework detect circuit is different. And we can see the first like the PP 1.8 voltage, and this PP 1.8 voltage is sent to the CPU, and after that the 1.1 voltage is sent to the RAM. And because the design of the CPU, iPhone CPU have two layers, and because the CPU have two layers, the lower layer is the CPU and the upper layer is the RAM. They are different. And as you can see, the CPU and the RAM, their framework detect circuit is different. If you have the experience, you will know that when you do the repair, a lot of the phone cannot power on, and possibly their circuit, the current is very small, the small current. Actually, this small current is mean that the framework detect circuit have some problem because the CPU cannot check itself. And normally this is case by the framework detect circuit have some problem. And how to detect it, where is the detect place? And as you can see in the PowerPoint in the TV, you can see it. And you need to confirm that the visitor and the other small component in those line is normally. For example, when we get a phone is water damage, and when you take out the motherboard to check it, you can see the visitor is burned, is big water damage. And because this visitor is in this framework detect circuit, so if the visitor is abnormal, this circuit also abnormal. Because another example, if the phone heavy drop down and cannot power on, because have a lot of components, small component in the motherboard. If those component is loose in this detect circuit, he will also cannot detect CPU itself, so he also cannot power on. So you can see in that place have a lot of point you need to detect. And now we going to talking about the I2C line, how it works. In the before, we have been talking about if the CPU need to check the low circuit, is use the I2C line to detect the low circuit, the low components. And as you can see in the PowerPoint in the PPT, you will see that have this 1, 2, 3, 4, 5, 6 have for 6 kinds of the I2C lines to control the low circuit and low components. And as you can see in the right of the PowerPoint, you will see that have I2C0, I2C1, I2C2, I2C SEP. And in the middle, you can see there have the I2C ISP and I2C SCL and the I2C. As you can see in the I2C9, maybe have 2, maybe have 3 IC, maybe have other components in these I2C lines. And how to detect the I2C line is normally or not. If the IC and the component in this line, in this I2C line, is normally is okay, and we detect the voltage is 1.8 voltage. And we can use the millimeter to test it the I2C line the voltage. When you detect the line have not the 1.8 voltage, we just focus on this line. In this line, the component, in this line, the IC and small things. But in this line have some problem case it cannot power on. And for example, when we detect the FaceTime camera, the cable, the I2C line, the voltage is abnormal. It's very easy to detect it. In this I2C line, just one thing, just one component. So we just need to detect this component is okay. And how to detect it? In this PowerPoint, in this PPT, you can see it. We have marked the test point, where it detects the point. We have marked it. You can see it detail, and when you meet this similar problem, you can detect it. Follow one step by one step to test it. And this is the PMU output detect data. And you can see the PMU have been sent out the 28 lines power to the whole motherboard. And in these 28 power lines have 15 lines is sent to the CPU. And as you can see, the red marks are the power lines for the CPU. And this picture, this PowerPoint is just in order to send to you guys, let you quickly to find out the problem of the PMU have problem or not. This have this test point, and you just test this point, those point, and you'll find out it have problem or not. It's very easy according to you use these ways to test it, because if you use the for example, I use the FIXST the software to find out the scientific to test it, it's so hard to one point to one point to find out it. We have this you, and you just follow this to test it is okay. And after that, we will show you is the NAND circuit, how to detect and reply, how to check it. Actually, the NAND circuit is very easy. If the NAND have some problem, we just need to change a new one, it's okay. If the NAND has some problem, we just need to change a new one, it's okay to try to change a new one to detect it, it's okay or not. But the NAND, the information inside the NAND also encryption. And we can use some machine to detect it, because the NAND information is encryption. And in the market, you can find out some machine. For example, the WL, for example, the JC, we can use those machines to detect it. And for example, we use the JC can provide the booting data of the NAND, and also can write the SN number and Wi-Fi MPT number in this. And how to detect the NAND is good or not. The NAND want to work normally also have two conditions. One is power. As you can see in the last PPT, you can see that the NAND have three kinds of the power. These three kinds of the power also all is from the PMU. One is 1.8, one is 3.0, one is 0.9 voltage. And the voltage is normal, and we can do the next step. We can check the NAND is normally or not. We need to remove it and try to change a new one, right? And when we remove the NAND, we can see a lot of point under the pan. We can check the communication line between the NAND and the CPU is okay or not. Check the line is the resistance is 0 or have big difference or normally. Okay, now we share some case about the no power on case to you guys to let you improve and learning faster. And now we show you the iPhone 8, the no power on problem. This iPhone 8 after tickets showing you a small current about 20 mA. And we have been talking in the before. The phone want to working normally, the CPU need to working normally. And the CPU is cannot working normally, and we need to check it, the power and the signal. And the clock signal and the reset signal. And when we detect the clock signal, it has some problem. When we detect the Y1000 24 amp hertz clock crystal, it has some problem. As we know that normally this should be 24 amp hertz, but actually when we detect have not 24 amp hertz, and the power also is lower voltage. And so that is mean that this clock crystal have some problem. So we need to change a new one and to test it. After we change it, the phone can power on. And okay, next one. And this is iPhone 8. The ticket power on is a large current and cannot power on. And this large current, this big current is the power supply have some problem. And this large current is caused by the NAND power have some problem. When we detect the NAND circuit, we need to detect the power of the NAND, right? And when we detect the 3.0 voltage about the NAND to the NAND, this voltage have some problem. And this, when we detect it, this 3.0 voltage, this line is short. It means that when the phone is power on, when the phone is turned on, and the NAND have not this power, and the NAND cannot working normally, so that the CPU cannot take out the booting data of the NAND, alright? So the phone cannot power on. And so we just need to repair this 3.0 voltage of the NAND, this power of the NAND. Repair this line is okay, and after that the phone can turn on. And next case, this is iPhone 8, and when we refresh it, the bar just going to 20% and showing you error 15. And as we know that the bar going to 20%, he is writing some data into the NAND. So cannot writing, so he show you error 14. It means that the NAND has some problem. So that this NAND has some problem, we just need to change a new NAND and troubleshooting. The phone can power on. And talking about the next case, this is the iPhone 8 Plus, and after the heavy drop, heavy flight, in case the phone restart and cannot power on. And when we detect it, the current is jumped from the 15 mA, and then it jumped to the 715 mA. As we know that this current is mean that the charging, the power have some problem. It means that the power IC of the motherboard have some problem. So when we test it and U3400, this wireless charging IC have some problem. And this wireless charging IC inside have the I2C line connected. And we have been talking in the before is the I2C line have some problem, also in case the phone cannot power on. So when we confirm that this IC have some problem, we just need to change it, it's okay. Okay, this is the next case. This is the iPhone 8 Plus heavy fry, and case when you power on, it show you a large current. And when we detect, we know that the CPU power have some problem. The CPU power is sent by the PMU, have two kinds of the power. And these two kinds of the power, one kind is the directly sent by the PMU, and the second is send it through the block current. And these two kinds of the power, one kind is the directly sent by the PMU, and the second is send it through the block current, the block circuit. These two kinds of the power, you just know that one is the LDO, one is the block current, block voltage. And what is the difference about the block circuit and the LDO circuit? Now we're talking to you guys. The LDO circuit is in the PMU inside. He have been let the power, the voltage is going down. And the block circuit is mean that in the PMU inside cannot let this power, the voltage is be lower, and he need to use the outside, use the block inductor, go past the block inductor to let this voltage to be lower. And what is the block inductor? We have been share you guys in the other teaching material. You can reach it, is okay. And when we detect, we know that the CPU power, the voltage, and the GPU power voltage have some problem. The voltage cannot be lower, cannot be blocked. As we know that we have been talking in the before, the power sent to the PMU is higher. If this higher voltage cannot be lower, is sent to the CPU cannot use this power, cannot use this voltage. And as we know that this high current is mean that the voltage sent to the CPU have not be lower. So we need to check the voltage. And then we find out this inductor have some problem. So we changed the inductor, the new inductor. This trouble is finished. So we show you the next case. This is the iPhone 8 Plus, and he will always restart with Apple logo and cannot power on. When we flash it, and the iTunes show the error is error 9. In the before, we have been talking about if the logic port have some problem, in which case the phone cannot power on. But in the iPhone 8 Plus, this logic port is special. This logic port is integrated in this M5500, this big inductor. And because this booster inductor have a lot of boost current, so this IC is very easy to have some problem. As you know, the high voltage will case very easy to case the component have some problem. And by the way, the logic port also integrate in these little things, so this IC is very easy to have some problem. And more important is the logic port is inclusion with the CPU. If the logic port have some problem, in case the phone cannot power on, cannot turn on. So after you change this IC, you need to flash, and then your customer, the user data have not. So I think that this design of this motherboard, I think it have some problem. And show you the next case. This is the iPhone X. When we press the power key, it have not any current. We have been talking in the before, if the phone need to power on, the PMU, the main power IC need to working normally, right? If this IC, the PMU have not work, so the phone have not any current, have any power. So if this PMU, this main power IC, if not work, we need to check his itself have problem or the working condition have problem. We need to check it the power on signal and the clock signal. We also have been talking before, the reference circuit have some problem. We also case the phone cannot power on. And where is this reference circuit? Here is in the R9 and R10 pin in the PMU. And the R10 pin is the reference voltage circuit, and the R9 pin is the current reference circuit. During our reply, we test it and we find out the R resistor, the R1000, 3010, this resistor have been missing. So if the PMU have knocked this reference circuit, it have not output the power. So in our repair, we just need to install a new resistor in this place. It's okay. Okay, now I'll show you the next case. This is the iPhone X. The power on current is jumped from the 215 mA and set in the 215 mA. He start in this current. He not move. And normally the power on the current is very big. Normally have some shock in the motherboard. And so when we detect it, we have been found out one line of the power to CPU. This power have been short. So we just need to focus on this line. And when we test this line, we find out the one capacitor have been some problem. This capacitor have some problem and it's short. And we just fix this and troubleshooting. The problem is finished. And so the next case, this is the iPhone XS Max, and the phone cannot power on. When we take it, and the current is set at 200 mA. And this no power on is caused by the communication with the CPU and the NAND. This communication have some problem, and case it no power on. Communication line of the CPU and the NAND, he have the PCIe 9. And this PCIe 9 is use the data exchange to the NAND and the CPU. So we just need to focus on this PCIe 9 and repair this PCIe 9 and troubleshooting, and the phone can power on. This is iPhone XS Max. When we power on, it with a high current. It jumped from 500 mA. This is similar like the iPhone X case we have been talking. This is the same. When we test it, the power of the CPU have one line, the power have been short. When we test it, we find out just capacitor inductor have some problem. We just handle these two things and the phone can power on. Okay everybody, this is the first class all the information. And if you have any question, you can ask in the Facebook group. We can give you the answer. And if you have repair problem, you also can ask and you tell me what's the problem, and we try to give you the answer. And our case strength is speak very quickly, and you also can see the more detail in the picture, and you can see the PPT, see the PowerPoint. And maybe you can come to China to enter our iPhone full training, and I will also teach you the test how to improve your hand skill. Thank you so much.